everyone, I'm going to be talking about nodal analysis. I'm going to explain a little bit about it and then solve some examples so you can understand more. First of all, first thing you need to know is about KCL or Kirchhoff's current law. What does Kirchhoff's current law says? I think you're probably familiar with it, but I'm going to explain it once more. Let's say we have a node A in here. Then we have some branches coming out of it. What does Kirchhoff's current law says? It's that all the currents going and coming from this one node A in our circuit are going to be equal to 0. What does that mean? Let me explain more. Let's say this one is current 1, current 3, and current 2, exactly with the directions that I draw. What we say, first of all, we need to define a conventions for ourselves. There is no rule. We can say when we have one node and then there is a current going through it or coming back from it, we need to consider 1 minus and 1 plus, so we can make it easier for ourselves and solve our equations. So what I say here is that if a current is going to a node, I'm gonna call it minus, negative that current. And if it's coming out of that node, I'm gonna call it plus that current. So what does it mean? Here, I1 is going to the node, so I'm gonna add 1 minus sign next to it and write it down, minus I1. What about our I2? I2 is coming out of the node, like in here, coming out of the node. So I'm gonna add 1 plus to it and write it down. I3 is exactly like I1, it's going through the node, so minus I3. All our branches have finished, so I'm gonna write equal to 0. As easy as that. So as you can see, if I take I1 and I3 to the other side of the equation, I'm gonna get I1 plus I3 is equal to I2. What does this mean? I2 is coming out of the node. I1 and I3 are going to the node, so sum of the currents that are going through a node are equal to the sum of the currents that are coming out of the node. One more thing we need to know in here is that we're gonna be, in nodal analysis, we're gonna be defining different nodes, and we're gonna be considering that nodes have some certain kind of voltage, and then we're gonna find it out. Let's say in here we have V1, we have V2, and we have one R1 in between, this resistance in between. What do we know? If we want to find the current here, what do we know about current? We know that I is equal to V over R already. Here we have our R, but what is the V in between? We know the V1 at this node, we know the V2 at this node, but what is the V in between? V in between is V1 minus V2 or V2 minus V1. But it depends, which current are we finding out? We can consider our current from this side to the other side or from the other side to this side, which, as we know, if this one is plus, this one is going to be minus. If this one is a negative number, this one is going to be a positive number. So there is only one sign change between this current or that current. What do we say? We say if we are considering the current going from V1 to V2, we say V1 minus V2 over R1. This is our current. If we are saying it's coming, the current direction is to this side, so we say V2 minus V1 over R1. So if we, let's say, considering it from node V1, we can use this one, and then we can say, because it's coming out of the node, it's plus. Or if it's the same exactly, are using the same node, but we want to use this current, V2 minus V1 over R1, because it's going to the node, as in here, we have to just add 1 minus sign to it. That's all we need to know for now. I'm gonna be drawing an example for you guys, and I'm gonna try to explain to you better. Here in this example, I'm not having any numbers because I just want to show you guys how to drive the equations we need. We're not calculating anything or like figuring out any number yet. It's just a simple circuit. We have three resistances, R1, R2, R3 are our resistances, and then we have two current sources, I1 and I2. First step in doing nodal analysis is to find one node and make that node our reference. What does that mean? Let's say this one is our reference. It means that we're going to connect that reference node to the earth. What does that mean? That means that the voltage in here is going to be equal to 0. And then we're going to find all the other voltages of all the other nodes compared to this one that we considered 0. I'm going to be naming this node 1 and this one node 2. Or we can say V1, V2 because we're finding their voltages. What we do is that we put one node as our reference node and then we're going to name all the other nodes. But here, as you can see, because there is no resistance in between, this node and this node are going to have the same voltage, so I don't need to name this one. Again, here the same thing are happening with this. All these three nodes are going to having the voltage of 0 because this one is having 0. There is no resistance in between, so they're going to have the same voltage. And same with these two, and same with these two. So actually we named all of them that are different from each other. How do we write our equations then? We're gonna go one by one to each node. The nodes that to our non-reference nodes, like node 1 and node 2. And we're gonna write the equations according to KCL. So we say node 1. And we're gonna write down our equation. So what does KCL says is that we have to write down all the currents going and coming from one node and make them equal to 0. Here we have three branches, so three currents. The first branch is this one. There is a current going to the node. So we said if it's going to the node, we're going to consider it a negative. We're going to add a negative sign to it. So we say minus I1. This branch done. The second branch. Here we have no current, as we can see. We have to calculate the current ourselves. How do we do that? We said, okay, because we are considering this one, we're going to consider the current going from this side to the other side. And this current, as I explained before, is V1 minus V2 over R1. And it's plus because it's coming out of node A. There is another current here for this branch, which is, again, we're going to calculate it the same way, plus, because we want it to be plus, we say it's coming out of the node. The current coming out of this node is V1. Then here we have another V, this V is 0, so we say minus 0 over our resistance in between, which is R3. So all our branches have finished here. We calculated all three of them, so we say is equal to 0. So this one can be cancelled because it's just 0, and we take this one to the other side to make it easier, to make it a more defined equation. So we get this. This is the first equation we're gonna drive for this question. Now we're going to the other non-reference node that we have, which is node 2. Here we have 4 different branches. We're gonna go one by one and write them down. See, first thing is this branch. Do we have a current? Yes, we do. And the current is coming out of our node. So we said we're gonna add one plus sign to it and write it down, plus I1. The second branch is here. We say to make it easier to be able to put plus again here, we consider the current in this direction. And if we consider it in this direction, we're gonna go V2 minus V1 over R1. Here, third branch. What do we write? Again, we consider it this way, our current, the direction. So we can write V2 minus 0, because we said the voltage in here is 0 over R2. We have a fourth branch. In our fourth branch, we have a current, so we don't need to be dealing with voltages and resistances. And our current is going to the node, so it's already minus, so it's a minus I2 is equal to 0. We cancel this 0 and then we take the current to one side, so we get I1 minus I1 plus I2 is equal to V2 minus V1 over R1 plus V2 over R2. This is our second equation. So we're done in here. I just wanted to show you guys how to drive the equations. In a real question, when we have numbers, we're gonna be, instead of R1, R3, I1, we're gonna have numbers. We're gonna write them down. And we have one V1 and one V2 which are unknown, and we have two different equations which we can find V1 and V2 easily from them. So now I'm gonna be solving one real questions with real numbers. Let's say example 1. It's just a simple, very simple question. So we can see if we land properly or not. Here, the nodes are already given to us. We know this is V1, this is V2, and this area is connected to Earth, so all these V's are 0. The question says find V1 and V2 using nodal analysis. So first things first, first thing we have to do is to define our nodes and which one is connected to Earth, which ones we're gonna figure out. That we already are given in this question. So second thing, what we do, we go node by node and we write our equations. Easy. Node 1, which is our V1. How many branches do we have here? 1, 2, 3. In 1, the current, we already have the current, which is 3 ampere, and the current is going to the node. So we said if it's going to the node, we're gonna add 1 minus sign to it and then write it down. So minus 3. We have another current here, which we don't know what it is, so we're gonna calculate it. How do we calculate it? We say if we can consider the direction here, we can just write a positive sign in here, and then we say this voltage minus this voltage over our resistance, which is V1 minus, here it's connected to Earth, so here our voltage is 0, minus 0 over 2 ohm. And then we have another branch. Again, if we consider the direction here, we add here plus. Say V1 minus V2 over 3, which is equal to 0. Here guys, because we don't want to not have any denominator, we're gonna multiply this whole thing by 6. So what do we get? We get minus 18 plus 3V1, because we know this one's already got cancelled, plus 2V1 minus 2V2 is equal to 0. From here, we have 5V1 minus 2V2 is equal to 18. We got our first equation. that we're gonna use and find our answer. The second one, we're gonna write the equations for the second node. Here we have again 3 branches. First one, here we say to make it easier to be able to put a plus in here, we say the direction of current is this side. And when the direction of current is to that side, we say V2 minus V1 over 3. So plus V2 minus V1 over 3. Here again we say the direction is here. Plus V2 minus V in here. V in here, what's the V in here? It's connected to the earth, so V in here is also 0. V2 minus 0 over 5. Here we have a current, we don't need to calculate anything. The current is going away from the node, so it's a plus 12 ampere. We don't have any more branches, equal to 0. Here again we want to cancel the denominators, so we're gonna multiply this by 15. So we say 5V2 minus 5V1 plus, this one is cancelled, 3V2 plus 180, which is 15 multiplied by 12, is equal to 0. Here what do we get? We get minus 5V1 plus 8V2 is equal to minus 180. Great, we found our second equation. How do we solve these two? I'm sure you all guys are familiar with matrices. Our matrix is 5 minus 2 minus 5, 8. Then we have V1, V2 is equal to 18 minus 180. And then we use our calculators to find that V1 is 7.2 voltage and V2 is 27 voltage. And we're done. Easily as that. I'm gonna solve you guys another example which is a little bit more difficult but still not too difficult. Because I want you to be familiar with all kind of questions. Here, it's again a very simple circuit, but this time there is a difference between this question and the other one, and I'm going to show you guys in a little bit. Yeah, here we know our knots already. We know this one is connected to the earth. This is 2, 4, 2, and 2. Here. What do we have in here? We call this a dependent source. We have independent sources like this one, which is, it's always 3 ampere. It doesn't matter whatever happening in our circuit. This is always giving us 3 ampere current. But this current source is giving us 2Ix. What is Ix? Ix is the current in here. So if the current in here goes up or goes down or whatever happens to it, this one is changing too. This one is always double times up this one. So it's dependent on this current. That's why we call this a dependent source and we call this an independent source. So how do we solve this? Okay, we don't know this current in here, but what we know, the current in here is equal to, we say Ix is equal to what? With the direction of Ix is going from V1 to V2. So we said this current is always V1 minus V2 over 2. As easy as that. That's all we need to know. So this one is equal to V1 minus V2 because it's 2Ix. And that's the only difference between this example and the other one. So I'm gonna solve it now for you guys to see. Not 1. First one. We have 3 different branches. we consider this current to this direction. So we can add a plus sign here. And then V1 minus V3 over our resistance, which is 2. This side, it's Ix and it's going out, so it's a plus. But what is Ix? We already know it from here, V1 minus V2 over 2. And then we have a current which is going to the node, which we say it's minus, so it's minus 3 is equal to 0. So we're gonna multiply this by 2, and we get V1 minus V3 plus V1 minus V2 minus 3 is 0, which gives us 2V1 minus V2 minus V3 is equal to, sorry, this is 6. 6. This is our first equation. Don't worry, you guys, here. I know we have 3 different variables in this questions, V1, V2, and V3, but we also have 3 different nodes, so we can have 3 different equations as well, and then we can easily solve it with matrices. So I'm gonna be writing the equations for node 2. What are the equations? We have one Ix that is going to this node, so we're gonna say minus Ix, or we can easily say we put plus in here and we consider our own current from this side to that side, and we say V2 minus V1 over 2, or we can say minus V1 minus V2, which is basically the same thing. Here we have another current, the direction this side, so we put plus here. We say V2 minus 0 over 2. Another branch we have here, plus, we consider the current this way, so V2 minus V3 over 4. We don't have any more branches, so we just say equal to 0, and then we multiply this by 4, which gives us 2V2 minus 2V1. Cancel this one, plus 2V2 plus V2 minus V3 is equal to 0, minus 2V1 plus 5V2 minus V3 is equal to 0. And we easily found our second equation. Our third node number 3. What do we have? Again, we have 3 branches in here. We say this one, we don't know the current. We're just gonna say the current is this direction, so we can put a plus in here, and then we say, because it's this direction, V3 minus V1 over 2 plus. Here, again, we say we put the direction to coming out of the node, so we can easily put a plus in here, and we say V3 minus V2 over 4. And here we have a source, which is the current, which we already know the current is V1 minus V2, and this from this source is coming out of the node, so it's plus, so we say V1 minus V2. We don't need really this parenthesis here, but anyway, we're done with all of our 3 branches which are going to this node, and then we say, so this one is equal to 0. Again, we multiply this by 4, and then we have 2V3 minus 2V1 plus V3 minus V2 plus 4V1 minus 4V2 is equal to 0. Minus 2V1, sorry, plus 2V1, because we have 4V1 in here, and then minus 5V2 plus 3V3 is equal to 0. Our third equation, we have 3 variables, we have 3 different equations, so we can easily find the answer by matrices. How do we do that? Write our matrices. Matrices is 2 minus 1 minus 1, 2 minus 1 minus 1, minus 2, 5 minus 1, minus 2, 5 minus 1, 2 minus 5, 3. And then we have our variables here, V1, V2, V3. And we have our answers here, 6, 0, 0. 600. Then we put this in our calculator, easy, and we find our numbers. The numbers may be looking a little bit odd, but it's just a practice problem, so I just basically made it up. But the most important part is to find the equations, find the right answer, and know how to solve this. I'm gonna be solving some more difficult questions in the next video.